Thank you. Boulder's actually in Colorado, but you know. What's 1,500 kilometers among friends? Thank you all for coming. This is a brand new talk. I'm curious to see how it will all go. It's a talk that is done in 3 parts that I've called, for reasons you'll see, the machine, the community, and the invasion. So we will start by talking a little bit about the amazing kernel development machine, the machine that cranks out the kernels that we all are using every day with almost the same regularity as this machine, which is cranking out beer, which of course is a very important kind of machine. So what is our machine cranking out? Here is the history of kernel releases over the course of just over the last year. We don't really need to go over them in detail, other than see that there's a bunch of them, with a whole lot of changes going into them, including 3.10, which is currently our record biggest development cycle ever, and a whole lot of developers going on there, generally coming out every 60 days or so. 3.13 is almost there, but it isn't released yet. I expect it to come out in a little bit over a week. So if you look at these numbers here, you'll notice a couple of trends that I think are worth pointing out. One of them is the number of change sets merged per release. We're now looking at the entire Git history here, starting at 2.6.12, back in 2005. So it's not the entire kernel history. But if you were to go back, you would see something very similar. You can stick a trend line on there. Since we have LibreOffice, we can do things like that. And see, I mean, the trend is obvious, right? We're adding more changes to every kernel release over time. We're getting busier. We're putting more code into the kernel over time. Our kernel releases are getting bigger. If you look at the plot of the number of developers participating in each release cycle, you see a similar trend, although you might conclude that it's starting to level off just a little bit. That's something I'll come back to. But we're seeing, again, an increasing level of participation in the process. There are more people helping to put out our kernels in every development cycle. So just to re-summarize that, the number of changes per release is continuing to grow, as is the number of developers. Now, if you've spent any time studying computer science and all that, you may have encountered a thing known as Brooks' Law, which says, and the way he phrases, adding manpower to a late software project is going to make it later. Now, the kernel, by most people's reckoning, is not necessarily late, although you could point out that after 22 years or so of developing, we still haven't managed to finish the stupid thing. But nonetheless, one could try to look at this and say, well, wait a minute, we're adding more developers to an already very big process. What's going to happen here? You know, if we have more developers, we've got more communications issues and more management issues as we're trying to get all these people to work together, right? The more people you have, the more paths of communication, the more ways that things can go wrong. More changes means more code to debug, to integrate, and to maintain going forward. Thus, one might conclude from looking at these numbers that our kernels should be taking longer to release over time, right? We're adding more stuff, we're having more people doing it. Seems like the process should be slowing down a bit as we grow in this way. Well, here's the actual plot line for the data here, which again, you can stick a trend line on. And you see that, in fact, we're getting the kernels out more quickly over time. They're actually coming out faster than they used to, with a pretty steady trend there. I will point out that 3.13 is actually going to be an uptick on that. It's going to be a blip upward and kind of break my nice trend line for the moment. But it's one of these exceptions that proves the rule situation because somebody, you can't see that at all, but this is a picture of Linus Torvalds in diving gear in an aquarium holding a sign that says penguin power. He has decided that next week he's going to go diving rather than put out a kernel and open the merge window. So because he's going to be goofing off, we're actually going to break our decreasing trend for one cycle only. But we assume he'll get back on track and we'll get back to it. So if you know me at all, you know that I'm into science fictional themes and all that. This is a guy named Werner Vinge who likes to talk about the singularity, the point at which the computers become smarter than we are, and they kind of take over. And people wonder, when is the singularity going to happen? And you look at trends with computing and all that, saying, when will the computers take over? Well, I would posit that if you follow this particular trend line forward, you will see that around 2027, kernels will come out in 0 time. So if you want to know when the singularity is, there it is. Prepare yourself. Okay, but seriously though, I don't know that the cycle can get a whole lot shorter in reality because it takes a certain amount of time just to find the problems in the code and so on. So I don't think we'll see that trend continue much longer, but I could be wrong. I have been wrong in the past. But we can go on and ask, okay, we're getting faster. Does that mean we're getting better? Or are we just sort of putting out these fast food kernels that aren't necessarily all that great? So one way of looking at this is we could say that the criteria for the release of a kernel is that there should be no known regressions, right? It should work at least as well as the previous kernel release that we made. Because you know that if you haven't broken anything that used to work, then you're not stepping backwards. As soon as you start to break things that work, you are going backwards. So one way of asking, are we succeeding in this goal? Are we succeeding in not taking steps backwards? Well, the stable release series is supposed to contain only important fixes, fixes for regressions and other important bugs. So here's the history of stable releases for the last few years. And we're seeing that, especially for the kernels that have been maintained for long periods of time, we're running up thousands of important fixes. So we're clearly not releasing bug-free kernels, right? But what we are doing is we're getting very good at finding the problems and routing the fixes into where people can use them, because these are the releases that distributors use to make their releases. At least most distributors do. Some kind of take their own path. But for the most part, they use these releases. So we're doing pretty well at finding the problems and getting them fixed. An awful lot of problems in a kernel release are only going to be found after the kernel has been released, because an awful lot of them are dependent on a particular workload or a particular set of hardware. And the kernel developers just don't have access to those workloads and that hardware. So they can't test a lot of things. Only the users can test kernels. That's what we have users for, is to test our kernels for us. So we're always going to find a lot of problems after kernel releases. I don't see any way around that. There's no way to fix that, even though we are getting better at pre-release testing in a lot of ways. And we're finding things that we used to. So even though we're fixing lots of bugs, thousands of bugs in our release kernels, I think that the general conclusion seems to be that we're not getting buggier over time, that we're not releasing kernels that are going backwards in quality. Maybe 10 years or so, people were really concerned about this. Andrew Morton was famously concerned that we were adding more bugs than we were removing. But if we had been doing that for 10 years, we would know that by now, because we would have really, really lousy kernels. Yes?
So there was the previous slide, there's a whole bunch. So you look at 3.3, it's got 8. 3.4, 75. And then you've got a whole bunch of low numbers. Why 3.4 and...
Okay, the question is why certain stable kernel releases have a lot more releases and fixes than others. And the reason for that is there's an effort called the Long-Term Support Initiative. And it ties in with how Greg Kroah-Hartman maintains the kernels, so that once every year, one kernel release is chosen for a 2-year maintenance period. Okay, that was 3.0, then 3.4, and then more recently 3.10. So that's why those particular kernels got a whole lot more fixes, because they were maintained for 2 years, or will be in the case of the later ones. 3.0 just went out of maintenance recently.
But it's not like backports? It's bug fixes?
It's all bug fixes.
Right.
In theory. In theory. It's not perfect, but the discipline's fairly good on that. So the other ones, most of the other ones are only maintained for one development cycle. So they get fixes for about 3 months. And then they go out of maintenance. So that's all these ones in the middle here are something like that. So that's why you see the difference with particular releases. You've got those, and then 3.2 is being maintained by Ben Hutchings. He's one of the Debian kernel maintainers. And that's what Debian based its release on. So they're maintaining it going forward. So anyway, we think that we're not getting worse over time, even though we could be doing a whole lot better, because it would be nice not to release kernels with thousands of bugs in it. But we're getting there. So my conclusion is that we are indeed getting better at doing this. The machine is working more smoothly. And so the next question that comes to mind, obviously, is why is this? How did this come to be? And so I pondered on this for a while, and I came up with a few perhaps plausible explanations. This one, unfortunately, doesn't work quite as well here as it does in the United States. This is a card that I received in the mail from a group called the American Association of Retired Persons. It's the lobbying group for old retired people that now has concluded that I should be one of their members. The point that I will make, and I'll come back to this, is that as a whole in the development community, we have gotten older. Right? There's a whole lot more gray hair for those of us who still have hair than there used to be in the development community. And what that means is a lot more experience. And we've learned very well over these 20-some years how to do this in a way that we didn't know back then when we were all doing this early on. With this experience comes a whole lot better discipline. If you ever looked at how kernel releases happened back in the earlier 2-something days and before that, we'd be, okay, we have a feature freeze, we're in the middle of a stable series, and then Lena says, okay, but I think I'll just replace the virtual memory subsystem because I like that one better. This happened. Okay, things like that. We don't do that anymore. We simply don't. We're very good at saying, okay, this is when the features go in, now we just fix things. And the development process that we have now, where we're releasing a kernel every 60 days or so, makes that really easy. Because if you don't get a feature into a particular release, you wait a couple months and there's another release coming and you'll get the feature in then. It's not that big a deal. So we've gotten much better at keeping out stuff that's going to destabilize our kernels before we release them. We can always get better yet, but we've made a lot of progress there. And the other thing that I would like to point out that some people might find controversial is the presence of companies working in this area. Right? As you may have heard me say in the past, something over 80% of the people working on the kernel are paid to do so. Right? This is not an effort done by kids living in their parents' basements and so on. It's very much a professional effort at this point, and the sort of professionalism that most companies expect extends to the kernel. They don't want their employees putting buggy code into the kernel. But beyond that, there are an awful lot of companies that are working very hard at teaching their developers how to work well with the kernel development process. There's a lot of in-company training that happens anymore to help make the process work more smoothly. That's where people learn how to do this, is within companies. And they've brought a lot of structure and a lot of help to get people up to speed with how our community works. And I think that has made a huge difference over the years. It has a lot to do with why the machine works as well as it does. So just to conclude for part one here, the machine is indeed working pretty smoothly and it seems to be constantly accelerating, at least for now. So that's how the development machine is working. So if we're talking about our changing community, the changes here is it's working better. But now let's think about the community itself for a little bit. Here are two pictures. You can almost see them. The upper one was taken at the very first kernel summit in 2001. This was taken actually at the 2012 summit, 11 years later. You may notice that there's an awful lot of the same people in both of these pictures, if you look closely. A few of them, Eric Raymond doesn't hang around anymore. And all that. But otherwise, you see a lot of faces that look the same. And in some cases, I think Alvaro hasn't actually even changed clothes between the two of them. We have a lot of continuity within the community, a lot of the same people. And there's obviously good things that come from this. But it's worth looking at how our development community is formed and how it's changing. So one question that people have asked me at times is, where does our code come from? And I've often answered this in terms of which companies have been supporting development of the kernel. But people ask me, where does it come from geographically in the world? And that's a harder question to answer. But I did figure out recently that you can look at the time zones and the date stamps in the commit history. And so I did that. These are the numbers just for the 3.12 development cycle. You can look at them for longer periods of time, and you think that are similar, but it gets noisier. Yes, was there? Asking about looking at the maintainer's location. You could do this, although that's harder because maintainers don't put timestamps. So that would be much harder to do, but you could look at the patches the maintainers submit, infer their location from that, and then map it back. So you could do that, but I have not done that exercise. But just to extend that a little further, if you look at where the maintainers are, almost all of the subsystem maintainers work for a very small number of companies. They're very concentrated. You find them at Red Hat, you find them at Google, you find them at SUSE, although less so than you used to. You find more of them now at places like Linaro. You look at about half a dozen companies and you have over half of the subsystem maintainers there. And those companies are pretty heavily concentrated in the United States and Europe, just to answer that. But looking at our development community, you see they're rather more spread out. So with some noise, you can actually attach locations to these time zones. And you get a picture that looks an awful lot like this. So if you look at the top, there's not too many people who are way out at GMT plus 10 or 11, depending on the time of year it is. That, of course, is Eastern Australia. You see a fair amount of activity coming from Korea and Japan, and some folks from the other side of Australia, which I hear is a very nice place to visit. I hadn't thought about that. That's good to know. There are a few unique time zones. One of those is that there are very few countries that are at GMT plus 5.5. But India is there, India and Sri Lanka basically. And so we're seeing a fair amount of code now coming from India. Now, it was not that many years ago I was at a conference on a panel with Atul Chitnis, who was a much lamented, very influential organizer in India. And he was complaining about how there were maybe half a dozen people in the entire country who were contributing code upstream. This has clearly changed over that time. We're getting a lot of code out of India, getting quite a bit of code out of Europe, of course. It has sort of moved from Western continental Europe. It's sort of spread out a bit more. You get a bit more out of the British Isles and more out of Eastern Europe than you used to. But still, a great chunk of code coming from Europe. Brazil and Argentina have their own time zone here, that and the far eastern Canadian seaboard, which doesn't contribute a lot of code. So you can see we're getting 5% or so of our code from that part of Latin America. And then you've got a whole lot of stuff from the United States. That has, again, it has actually shrunk a little bit over time in a percentage basis and moved eastward. That, alas, is my time zone. I'm working on fixing that, but doing the best that we can. So if you just sort of boil it down, you'll see that we're getting, roughly a third of our code from the Americas, a bit more of that from Europe, and 20% in some and growing from Asia in general. Yes?
Just what I did last time, the previous slide.
Yes.
Is the plus 12, plus 11 in New Zealand and sort of related bits, are there people contributing from there, or are they just too small to show up?
There are people, and you can almost see a little tiny square from the very far end of it. But yeah, I don't know that in the kernel space there's a lot of people from New Zealand.
So there's some, just not very many.
Yeah, just not a whole lot from there. We've got to work on that. So anyway, that's kind of where our code is coming from geographically. Like I said, it's moving more towards Asia over time. It's the biggest change that you see in that area as people come up to speed there, and especially in the last few years from China. There's been a lot more code coming from China in those years. So that's kind of where it's coming from. One might ask, well, what is happening with our community? Is it growing? I alluded to the plot of the number of developers per release kind of leveling off. So it's worth asking, is our development community growing? Well, the people at the Ottawa Linux Symposium answered this question a few years ago. In one way. So I think that's Craig Ross. You got a credit for that, not me. So anyway, but that's not the question. That's not the question that I was seeking to answer. Okay, no, are we getting more developers, not bigger developers? And so I went through and I looked at the commit history, kind of keeping track of the first time that we see every developer and when they commit, and came up with this plot of how many developers contributing to each release are doing so for the very first time. And the software that I have is pretty good at dealing with people with multiple email addresses and all that. So most of that noise is not there. And so you see something that looks, to a very first approximation, like a linear sort of constant number of people, maybe slightly decreasing number of new developers coming in for each release. The second line here is what I'm calling long-term developers. These are the people who show up for the first time in a given release and then contribute to at least 3 more kernel releases after that. So people who come in and actually stay around for a while. That seems to be dropping, but I wouldn't read much into that because it takes a while for people to build up their 4 releases over time. So that will actually straighten out over time. But you see this sort of rough line here. If you then look and say, how many people were contributing to a particular release for the very last time? How many people did we see for the last time? And you get a line that looks like this. And so over time, the number of people making their very last contribution to the kernel is growing. So in a sense, this would make sense. If you think about, if we have a development community it seems like maybe we have people coming into it at a roughly constant rate. Whatever it is that brings people into the kernel works such that they come in at a roughly constant rate, very roughly. But in every release, you're going to lose a certain percentage of your developers. Then you're going to see a couple of lines that look like this, right? Because as the community grows, the number of people who will leave the community because they decide they'd rather be PHP developers or gardeners, or they get arrested or whatever else goes on, will tend to drive that line up. So, right, things cross somewhere right around 3.2. Those two lines crossed. And it looks like we maybe have more people leaving our community than we have coming into it. And again, this is noisy. Some of the people who showed up as having left here will then make another contribution here and fall off that line. So it gets noisy as you get towards this end of the line. You have to take that into account, right? These are really fuzzy numbers. But there's a clear trend there regardless, right? This is a recipe for growth of the development community leveling off over time until you get to a point where those two rates roughly equalize. So I suspect that this may be what's going on here, is that we are getting to a point where we may not grow a whole lot more in terms of the number of developers unless something changes. Now, whether this is a bad thing is another question altogether. I mean, Linus has said that we really don't need to get a whole lot bigger than we need to. We're already pretty much the biggest project out there. Certainly the biggest working on a single code base like that. So we're awfully big. But it's something to bear in mind, that we may not get a whole lot bigger. The other thing, though, that I've been looking at for years is this plot here. This is the number of people contributing who are working on their own time, as opposed to working for some company. And again, there's a very clear trend that over time, the number of people working as volunteers on the kernel has been dropping. Has been dropping for years, and I don't really see any change in that trend. So you can ask whether this is a problem or not, because whether it is depends on your point of view on this. Yes?
Sorry, because of those percentages, are the physical numbers dropping, or is it just
the physical numbers are dropping. The curve is less steep, but yes, the physical numbers are dropping over time. If you go from over 20% of your community to often less than 10 now, that's the way it is. Yes?
Is it possible that the volunteers got hired by the companies? So it may be.
Sorry, ask the question again.
Is it possible that the volunteers who were working, they got hired by companies? So that way. Okay.
I can make slides really fast when I have to. The question was, is it possible that the volunteers are just getting jobs? And I think the answer is that not only is it possible, but it's demonstrably true. Because if you show an ability to get code into the kernel, people start to come after you, right? So the people who are doing this as a volunteer really kind of have to want to be, for one reason or another at this point, right? If you want a job and you show that you can do it, then you can have a job at this point. The market is like that. So yes, that's one aspect of it for sure. But whether it's the whole story, I don't know, right? The other question that you can ask is our community becoming more approachable, harder to come into as a volunteer in the first place? So, and one can look at this in two ways. There is the whole question of whether we're just too mean to each other and too nasty and that we drive a lot of people away. And it is an issue of concern. It's something to pay attention to. But I also think it's overstated, and it also has demonstrably gotten better over the years. You look at how we used to talk to each other in the 1990s and how we talk to each other now. Well, once again, we've all gotten old, and we just don't have the energy to tear into each other the way we used to. But it's still, that's an area to pay attention to. But the other really legitimate concern was best phrased by this. If you haven't read this file, you should, in the kernel source. The kernel has gotten very complicated. The easy problems to solve are long since solved. And we've reached a point where the scalability demands placed on much of the kernel and so on make it so that you have to pay attention to a lot of things that you didn't used to have to pay attention to. So things like memory barriers were once hidden way down deep in the mutual exclusion primitives. You didn't even have to know they existed. Whereas now we have at the Kernel Summit people giving tutorials on how to place memory barriers in code because you have to do this kind of thing. I blame Paul. He's kind of made all this stuff happen to us. But,
part of it is that we're just finally admitting how mean the compiler can be to you.
As Paul says, we're only now admitting how mean the compiler can be. It can really and the compilers are getting meaner. But so it's getting harder to get going with kernel development than it used to be, and that's kind of a concern. You used to be able to come in with not a whole lot of skill and do that, but now you used to have to. And so between these things, we have this trend that I've already put up. The number of volunteers seems to be dropping over time. So might this have something to do with the leveling off of the growth of the development community? How important are the volunteers to our future development? It's common to sort of look at the volunteers as being our recruitment area, right? This is where people come into the community. So I wanted to figure out if that was really true or not. So I looked at, once again, the first-time contributors. This is now starting with 3.0 and saying, where were people working when they contributed their very first patch? When that first patch was brought into the kernel, what was the employment situation of the person involved? And what you see is an awful lot of people working for companies. The volunteers are here, so it's a fairly big percentage. And then an awful lot of unknowns, because it's hard to know, because a lot of these people, among other things, don't necessarily hang out for long, and you can't figure out where they're working. You can plot this up another way, and I did this. These groups of bars are roughly once a year, every 5 kernel releases. So we're seeing in each case, the number of unknowns, the number of volunteers, the number of people working for companies, any company at this point. And what you see here is that more than anything else, people, when they make their first contribution to the kernel, are already employed by somebody, right? The bulk of our first-time patches are not coming from volunteers, they're coming from people who are employed. So, in fact, more recently, the number of volunteers contributing first-time patches has dropped quite a bit. So what this says to me is that volunteers, while they may be important, are not, in fact, our biggest source of new developers. That we have people coming in from other sources, and once again, as I mentioned early on, we have people working for companies and being trained up on how to do it there. But I think the volunteers are still important for a lot of ways, and I want to really pay attention to what's going on with volunteers and to keep them as a good part of our community, because I think they bring a different kind of energy and a different set of priorities. So just to summarize that on part 2, the community is growing for now and spreading out globally, but we may not get a whole lot bigger. And again, I don't know that that's necessarily a problem, but it is something to watch out for. So, final part is something that I call the invasion, and we'll see why I've come up with this term, but I want to start with the fastest history of the kernel development community that you've ever seen, because it fits into a few slides. But if you think about the first 7 or 8 years of kernel development, there's a period that was really pretty much dominated by hobbyists. People were working on Linux in these days because that was what they wanted to do. Almost nobody was getting paid to do this work at this time. And I picked 1998 because that was the year that Alan Cox got a job working on kernel development. Right, until Alan could get hired to do this, not too many people could. So that was kind of the line I drew. And 1998 really was when things started to change commercially with Linux at that point. And then we went into a period where Linux was to a great extent driven by the needs and the money behind enterprise computing. Right? There's a whole lot of stuff being done with Linux, but if you look at who was being paid to do this work and what drove this work, it was enterprise computing that did it. Right? That was where we got multiprocessing and our file systems and all that sort of stuff that we now depend on to make our mobile phones work. But at the time, that was all big iron stuff that the enterprise people needed. And that was all driven by those folks at that point. But then things started to change somewhere right around 2009 in what I am now calling the mobile and embedded invasion. And we have a whole different set of developers coming into the kernel. And I picked 2009 because that is this little inflection point right here. We're looking at the percentage contributions to the kernel sponsored by a whole bunch of companies. The first line is that same volunteer line that you've seen before. We've got companies like Red Hat and so on, various lines that are very roughly linear, right? And then the ones that I have put in bold there correspond to TI, Samsung, and Linaro, right? So these 3 lines all correspond to contributions from the mobile and embedded world, and really just a small piece of it, but we see that they've already come up to be a very significant portion of what's going into the kernel. Linaro is the number 3 developer in number 3 contributor in 3.13 at this point. It beat Red Hat. So there's been a lot of growth in this area. So this growth, of course, hasn't been all that smooth. It had its own set of stages. So the first stage, actually kind of prior to this period, is an era that was termed by Thomas Gleixner the embedded nightmare. We had companies working in embedded Linux before 2009, but they tended to keep all of their code to themselves. They were just doing their own things. They shipped it. They often kept it proprietary even. It really didn't work very well at all. And so an awful lot of developers spent a lot of time beating on the mobile and embedded world, saying, you folks, you've got to work with us. You've got to get your code upstream. This just isn't going to work very well. And so they started to listen to that. And what they started to do was to work in their own little sandbox in a little part of the kernel. And rather than think about, say, long-term maintainability issues in the kernel and so on, they just kind of threw everything in wherever it kind of landed. And so parts of the kernel started to look an awful lot like my daughter's bedroom. She was in the audience the first time I put this slide up. She really hates me still. Right, it was very messy until Linus just threw a fit and said, this cannot continue. You guys are going to have to do something about this. And so this part of the community got its act together and started what I'm kind of considering the march towards the core kernel. And the way I want to describe this is to look at some contributor numbers here. So if you look at the contributors to just the part of the kernel that corresponds to the ARM subsystem, right, the ARM architecture support, it looks like this, right? And you see a whole lot of companies that you would expect to see, right? Linaro, TI, ARM, Samsung. Companies like this that you would expect to be working on embedded Linux are in fact working on the code that is specific to ARM processors. But if you look now at who is working on the core kernel, you see a very different story, right? You see companies like Red Hat and IBM and SUSE and Google, right? NetApp, Oracle, not exactly mobile and embedded companies. So there's a very real, you can think of it as a disconnect in that these mobile embedded developers who have been coming into the kernel development community have not yet found their way to the core kernel, right? Those folks, this stuff is still being driven by the people who've been there all along working in the enterprise world. That's really where the core kernel development is being done. And a classic example of how this works has to do with power efficient scheduling. If you think about the needs of the ARM architecture, think in particular about a thing called big.little, which is a very strange architecture that ARM has come up with fast power-hungry processors and small power-efficient processors all in the same CPU die. And so this presents an awful lot of very interesting scheduling challenges that no operating system actually is prepared to handle at this point. The way the mobile and embedded community solved this problem, or is trying to solve this problem, is instructive. There are 3 solutions to it. The first one is they just put the solution into a hypervisor, ran Linux on top of the hypervisor and hid it entirely, and just sort of switched Linux from one set of processors to the other without even knowing about it. Just like, okay, let's not even try to touch the kernel. Okay, solution number 2 was to use the CPU frequency mechanism and make it look like a wide range of CPU frequency scaling. And they solved this problem that way with code that was held proprietary for a fair while, unfortunately, and all that, entirely in the ARM architecture subtree, right? They didn't go anywhere near the scheduler to solve what is fundamentally a scheduling problem. And then finally, they tried to solve it in the scheduler, and then they ran into a brick wall. And they've not been able to get this code anywhere near towards being merged. And there's a lot of good reasons for this. It's not ready to be merged, right? There's a whole lot of stuff that needs to be done before that code will be ready to go into there. But they've found it very frustrating. They've not yet been able to penetrate somewhere where they really need to be able to work. And so one might ask, well, you know, are the graybeards dominating our community and keeping this new sort of crowd of insurgents out? And I think that's not true. I think that's not what's going on. There's no desire to do that. But what there really is a strong desire driven by 20-some years of experience that this new code that comes in has to come in without making things work worse for everybody else that already works. And that's a really hard problem to solve. And so before this sort of invasion of new developers from a new community can get to the core kernel, they're going to have to really work with that community and get that stuff in there. And it's going to take a long time, but it's happening. They worked first only in the ARM tree. Now they work throughout the driver tree and all that. And they're getting closer to the core. And they'll get there as well. So we've got this new generation of kernel developers coming in. It's going to change the nature of how core kernel development is done as the nature of computing is changing. And the good thing about Linux is that we can actually follow along with that. We will do this. And we will accommodate these people and get them in. Because our community has been dynamic and mostly inclusive and growing for something over 20 years now. And I think we will continue to do that, but we should still think about how is it that we can do better for the next 20 and bring these people in the generation that comes after that as well. And that's really what I have to say about what's changing in our community, but I would be happy to answer questions for anybody who might have any other questions. Yes?
Is it possible that the lack of contributions from the embedded folks to the core kernel is just because of a lack of interest, and maybe the file system layers are already good enough for embedded, maybe the becoming power management infrastructure layers is good enough for embedded?
Okay, the question is it possible there's no contributions to the core because of a lack of interest, because everything that's there is already good enough? And the answer is no, it's totally not good enough in any way. They need to do it. They are interested, but there's an interesting situation that, again, Thomas Gleixner once called the platform problem, where you look at the area of the code that you're working in, say the ARM subarchitecture tree, and everything else looks like an immutable platform. And so if there's a bug in the core kernel, you don't fix it in the core kernel, you work around it in the ARM subarchitecture tree. And we've seen a lot of that kind of stuff. And that's really not how things should be done. You fix problems where they are. You don't try to work around them somewhere else. But you have to train people to do that because they have their area that they're comfortable in. And they look over here and they see, this core kernel stuff that's maintained by all these really big name kernel developers. And they're afraid to touch it. And it takes a long time to get over that and to submit patches to that. And then you get slapped down really badly for submitting a bad patch. And then you have to pick yourself up and do it again and so on. So it takes a long time. Yes?
Someone like Red Hat was doing a lot of that work. They're in the server market and maybe doing this cloud. I guess two questions. One is, do you see cloud becoming a major role? And two, do you see Red Hat moving into embedded if they need to follow this?
Okay, the question is, do I see cloud computing changing this at all or coming into it, and do I see Red Hat moving into embedded? For the first part, cloud can, in a lot of ways, be thought of as an extension of enterprise computing, in terms of how it works. So, they drive things in terms of virtualization more than others and so on. And, interesting things will happen, but I don't think they have unique needs in quite the same way. Some of the stuff that's happening, say, with control groups or whatever, I think is driven by that. All the sort of partitioning stuff that's going on. In terms of Red Hat's product plans, I can't really answer those. They have a fairly evident public interest in things like ARM servers. And so, moving towards the ARM architecture, at least in that area, even though there are no announced products and nobody has told me of any product that will happen. But it's not that hard to see that that's coming, right? So, they'll come closer to that. And that, actually, the ARM server thing, if it succeeds, is going to force some interesting interactions between these two communities.
How do we better engage vendors that are still badly behaved in their own sandbox, that aren't contributing upstream that much?
How do we better engage the companies that are still behaving badly, not contributing upstream that much? The same way that we always have, which is that we browbeat them, we nag them, we do not support their hardware well because we can't. And we let them make mistakes for long enough until they learn that their lives are really easier once they do that. And this has happened over and over again. We've had recalcitrant companies that eventually figure out that it really just works better to get their code upstream. And they suffer a lot less. And don't buy their products. Yes, that works too, and that is doable. Anybody else? All right, well, if not, then I will thank you all very much.